Good morning, this is Kavi Priya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic adder from the subject Digital Electronics. This is my flow of presentation. I am going to discuss about what is a combinational circuit, what is the difference between a combinational and sequential circuit, classification of combinational circuit, then about adder, half adder and full adder. First, what is a combinational circuit? In combinational circuit, the output at any instant depends only on a present input. It doesn't have any memory element, so output depends only on the present input. Examples for this combinational circuits are adder, subtractor, multiplexer, demultiplexer, encoder, decoder. So the circuits which can be implemented using basic gates comes under this combinational circuit. And next is what is the difference between a combinational and a sequential circuit? The basic difference is that the sequential circuit consists of a memory element, whereas combinational circuit doesn't have a memory element. So in combinational circuit, the output at any instant depends only on the present input, whereas in sequential, the output depends on the present as well as the past input. Examples for this combinational circuits are adder, subtractor, mux, demux, encoder, decoder, whereas for sequential circuit, flip-flop, latches, counters, etc. And next is a adder. Adder is a combinational circuit which takes binary inputs and it performs a binary addition on the binary inputs and it produces the output which is nothing but it is a sum and carry. It can be of two types. It can be a full adder and or it can be a half adder. In case of a half adder, it operates only on the two binary inputs, whereas full adder operates on the three binary inputs. So these adders plays a major role in microprocessor in arithmetic and logical units. It is an important component of microprocessor as well as the ALU. And this is a combination, this is a classification of this combination circuit. It is broadly classified into three categories: arithmetic and logic function, data transmission, code converters. Adder, subtractor, comparators, PLDs comes under this arithmetic and logic function. Mux, demux, encoder, decoder comes under the data transmission. And the code converters, we have this binary BCD 7 segment. And next is a half adder. So half adder is a combinational circuit which takes two binary bits as the inputs and it produces a sum and carry as the output. Here A and B is taken as the input and the output of a half adder is nothing but it is a sum and carry which is an output. So this is a truth table for this half adder. Since it operates on two bits, the combinations of input will be from 0, 0 to 1, 1. The sum will be 1 when input is 0, 1 and 1, 0. And the carry will be 1 when input is 1, 1. So if we apply this K map on the input bits A and B, and we'll be getting a Boolean expression for sum and carry, which is nothing but sum is equal to AX or B, carry is equal to AB. And next is what is all the advantages, drawbacks and applications of a half adder. The main advantage is a simplicity and it is of high speed and it is cost effective since it involves only the basic gates. Drawback is that it doesn't contain this carry in input and it is of limited functionality when compared to the full adder. And while cascading operation, this half adder is not suitable. Applications are, it is a building block for this full adder, counter, encoder, decoder, etc. And next is a full adder. The full adder is one which takes 3 bits as an input and it produces an output which is nothing but sum and carry. So the inputs are taken as A, B and C in and output is taken as sum and carry. So the sum will be 1 when input combinations are 001 and 010, 100 and 111. Whereas carry will be 1 when input combination is 011, 101, 110 and 111. And if we plot the K map for the sum and carry, we'll be getting the Boolean expression for sum as AX or BX or C, and for carry it is BC in plus AB plus AC in. And we can draw this logical diagram using this Boolean expression for sum and carry. And next is a puzzle, which is an activity. A storage element that holds one bit information is nothing but it is a flip-flop. The gate which produces all inputs are I. What a gate which produces when all inputs are I is nothing but when it is a 1. And the universal gate that is a complement of two input AND gate is a NAND gate. The type of a circuit which output depends only on the current is nothing but it is a combination. If a circuit depends on both the current and the past input is a sequential. And next is what are all the advantages, drawbacks and applications of full adder? The main advantage is that it is a fundamental for the multi-bit addition and its speed is high and it is highly efficient when compared to the half adder. The drawback is that the complexity will be increases in case of full adder when compared to the half adder, and the power consumption is also very high when compared to the half adder. And there is a chance for the propagation delay in case of this full adder. Basic applications are it can perform the arithmetic operation and it has been widely employed in the calculators and other digital devices. It can be used in timers and other program counters. It is mainly useful in the digital signal processing. And next is the assessment questions. How many inputs does the full adder have? It can have 3 inputs, whereas in case of half adder, the number of inputs is nothing but just 2. To add two binary numbers, which of the following is used in parts of a processor? Definitely adders are used. What is the main limitations of a half adder is nothing but it can't accept the carry from the previous stage. The Cin is not available in case of the half adder. That is the main drawback. So that's all about the adder part. We have discussed what is a combinational circuit, what is the basic difference between a combinational and sequential circuit, and even discussed about what is an adder. And in depth, we have discussed about the half adder and full adder. And finally, we have discussed about the advantages, drawbacks, and applications of both half adder and as well as a full adder. Thank you.